Hey everybody, this is Mr. Vance here. I'm going to be behind the camera today, but here I am. And we're going to be talking about density. To do that, we're going to make a density column. So first, just thinking about density itself. All objects have some sort of density. And the density of an object is essentially just how filled in the object is. If you remember the equation for density, it is mass divided by volume. If you think about it, that's the mass, how big it is, or how heavy it is rather, versus divided by the volume, as in how the size that it is. And so how filled or how heavy it is in terms of how much it weighs or how big it is. So here I have a feather, right? And this is just a small little feather. And obviously it doesn't weigh very much. But of course, if it was really big too, it probably still would be very light. It'd be as light as a feather, you might say. And that's because a feather is just not very dense. And so now we're going to be looking at liquids and their density. And here we have 1, 2, 3 different liquids. This is honey, this is vegetable oil, and this is soap. I know these are not advertisements, but I wasn't going to strip all these things off. These are just all things in my kitchen. And because they have different densities, they're going to interact in some weird ways with each other in our column here. In this case, just a glass. Let me go ahead and start by pouring vegetable oil. Get that in there. When you're making your own density column, by the way, try to pour things very slowly, especially if you're dealing with anything with water. So now let's go ahead and go with our soap. Here we have just normal everyday dish soap. And think right now, before we get started, do you think it's going to sit on top or is it going to go to the bottom? Let's find out. It's sinking down there. Hopefully you can see that. But is it going to stay there? We have some bubbles rising to the top, but all things considered, we have it sitting there on the bottom. The bubbles, I think that's just the force of these little air bubbles that are pushing their way to the top. And now we have some honey. It's very thick. I had to actually heat it up a little bit. So this is going to probably be the slowest pour, but let's see where this honey goes. And that's something to think about as we watch this honey slowly get down towards the bottom of this glass. Do you think the thickness of a liquid might have something to do with its density? Or perhaps, does its density have something to do with its thickness? There we go. This honey is unfortunately the same color as, or at least pretty similar color to our soap. I didn't have a green soap. But still you can see a difference. And if you look, sure enough, on the bottom, oh, we're getting a little extra help from Simba here. He is a scientist in training, as you can see. Sure enough, we have a very dark liquid on the bottom, and that is the honey. And if you compare here, all right. Thank you for your cameo. If you see, sure enough, this dark liquid, the honey here, is the one there at the bottom. So the honey, the soap, and the oil. There's a lot of different liquids we could have used here, and we could even take some objects and drop them in and see where they might float. Some of them might float on the top, but others might not. They might actually sink to the bottom or maybe just on a surface somewhere in the middle. So I'm going to leave you with one challenge question here. Go ahead and get myself in the frame. One challenge question I'm going to leave you with to think about. Although it's true that these are non-water liquids, right? They're, soap and honey and things like that. They do have different densities. And so they are stacking on top of each other. Do you think it would be possible then for different bodies of water to exist within other bodies of water? Is this only possible because these are not water, or do you think it actually would be possible to have a lake underwater in a lake, right? A lake within a lake, or a lake within an ocean? Go ahead and think that to yourself and think about maybe why or why not. All right, see you next time.